Hello everyone. I took this alternator apart a few months ago, and when I put it back together I noticed that these two spacers, they seem like they're non-conductive, were remaining. So I'm going to open it up today to see if I can find where these go. And I have an idea, but let's see what I can find. So I'm going to open up the alternator again. And I am considering doing some testing with this alternator for the scooter. I know I didn't put it in the title, but the scooter's still here, the scooter project. This is the electric scooter with alternators, permanent magnet alternators on the back. And then the motor back there. That's the motor. But I'm going to open up this alternator, and I might do some testing with the alternator as well, with this alternator. I'm not planning on doing any testing today, but I was thinking the sprocket might fit on there. I'll have to drill this hole out, or maybe order a different sprocket that has a larger hole, whichever size this hole is. But mainly today I just want to open this up and see if I can find where these two spacers go. I think they go somewhere between the I think this has a built-in bridge rectifier. I'm not sure if it has a built-in voltage regulator. I don't know if it has a built-in voltage regulator. But I know it has a built-in bridge rectifier, which would convert the AC that the alternator produces into DC. Okay, I need to get some tools. By the way, for those of you that are following the scooter project, we're still looking for a high voltage speed controller. So if you have any ideas of where we can order a high voltage, which is, we want to go around 96 volts, you know, for like a minimum of 48 volts, but we want to be able to also go to 96 volts as well. So something that can go up to 96 volts or is adjustable. I don't know if they have a volt, speed controls that can take various voltages from 48 up to 96 or even higher. So if you have any ideas about where we can get a a high voltage speed control for this scooter, let me know in the comments on the bottom of this video once the video is posted. Really appreciate that. We're thinking about looking at motorcycle. I think there's a motorcycle, it's called the Lightning. I think it's like the fastest motorcycle in the world. It's very fast, and it's an electric motorcycle. So we were kind of looking to see what kind of speed control that uses. We're not trying to go for high speed with this, we just want to go with high voltage. So we're just trying to, Ellery, my girlfriend, was talking about looking at motorcycle speed controls as a possibility to go high voltage with the scooter. We're also considering using possibly a electric car speed control for the scooter, because we want to go high voltage. So we want to be able to go really high voltage on this, and high voltage is more efficient, so we're open to that. So meanwhile, we're looking for a speed controller that's high voltage, 48 volts, and 96 volts. That's the range we want to experiment in right now. We're also looking for a high voltage transformer, DC to DC transformer, that will step up the voltage, possibly from the batteries to the controller. But first we're going to test from the controller to the from the controller to the motor, and bump the voltage up and see how that does, because we know high voltage is more efficient. That's what we're seeing, so we want to do that. This video is primarily about me opening up this alternator. So I'll be opening up this alternator here. I just have to get some tools. But if you have any ideas where we can get a high voltage controller, or if it's, adjustable high voltage, or we can adjust it. Even several hundred volts is okay, but I know we want to go to a minimum of 48 volts and up to 96 volts, but higher than that's okay as well. Okay, let me get some tools. And if you noticed in this video, we're back using the this end table or dresser as a stand, because the stand that I ordered, that we had, the scooter stand that we were using, the motorcycle stand, it was leaning the scooter forward. It wasn't perfectly flat, so we just sent it back. We don't know if it's defective or if that's just how they're made, but we sent that back. So we're in the market for looking for something else to raise the scooter up and lower it down, so I don't have to pick it up off of this table every time I want to run the scooter on the road for testing. But we can do a lot of our testing here on this bench test here. So let me just get some tools and I'll open this alternator up. Excuse me. Looks like the last time I opened this, I didn't tighten everything back down. So we'll go ahead and, looks like this one might go right there on this. Because I can see an indentation in this right there. It's the shape of the head of that bolt. I think that's where that one goes. That one already has one on it. It already has a spacer. Okay, so I'll go ahead and pull these springs out for the brushes. Okay, that's the one. This wire looks pretty thick. I think the auto parts store, when they did the test on this, I think they were saying this was a 50 or a 60 amp alternator. I think the thicker wire is more amperage. I think that's what I was reading. So thinner wire would be less amperage, I think. Okay, so I'm going to go ahead and take off this. I don't know how all this works. These here, I don't know what these are. I mean, they kind of look like capacitors, but I'm guessing they're diodes. That's what I think these are. I think these are diodes that convert the AC signal into, oh, this is a capacitor right here. This is a capacitor, I think. That looks like a capacitor to me. So that, to me, that looks like a capacitor, and I don't know for sure, but that's just what I think it is. And I think these are diodes, which are quite big, actually. Oh, that's where the power comes in to charge the field. Which magnetizes the center of the alternator, the rotor, and then that produces power when it's spinning across the copper coils. Okay, let's see. That's what it looks like it does. That's how it looks like this works. That's how it seems to me how it works. Okay, I'm gonna take these off. And oh, I think this will have to be taken off too. Okay, let's open that. Okay, that was holding this plate on. Okay, now the plate should be able to come off. And I need to see where I can put my... Okay, yeah, I think a spacer goes between these two. Let's see. Oh, wow, that doesn't have one, does it? Oh, wow. Okay, well, no, I'm not sure. I got two of those. Oh boy. I'm not sure where these spacers go. I'm trying to find where these spacers go, because I've had this open before and I see one here. I don't see one on the bottom. Gosh, I don't know. Well, let me put the ones in that I know where they go. So it looks like this one definitely goes here, because just looking at it, I see the shape of this pattern here. The pattern of this, the head of this bolt is the same as that indentation in that. So I think that goes there. That looks right to me. Wait a second. Okay, maybe not. Wow, because the center is perfectly round and this one's not. This has a... it's not perfectly round. Whoa. That makes me wonder if this is missing a piece. Okay, let's see. Let me look at this again. This goes through here. You know what? That makes sense that there's no washer here, because that's meant to lock into that. That's the same shape, so that's meant to lock in there. Oh, but this one has that too. But this has a spacer in it. Yeah, okay, so this one does... Okay, this is starting to make sense. This is making sense now. Can't believe it. Okay, I think this goes here. Let's see. That shape matches that. The shape of this hole. It's larger. Yeah, that's that. That goes there. That goes there. Okay, this goes here. This one... let's see what this looks like. That definitely looks like that goes face down right there, because it has that shape on it right there. There's a ring in there, like an indentation, the shape of that. So that goes down right there. Okay, we found... that's it. I can't believe it. This is great. Well, at least I'm getting this put together the way it's supposed to be. I think the first time I did this, I didn't know how to put these spacers, so I was too tired to try to figure it out at the time, so I just kind of put it together, and I thought I'll come back to it when I have more energy, which is now. And I got to learn more. Okay, the spacers are all in place where they belong. All right. I know when I put the brushes in, I used a... and we'll get to that part, but I just want to kind of look at it now real quick. Yeah, there's a hole there. And I'll show you with... oh, I think you can see it right there. There's a hole in there, and I put like a needle or something long through there, like a sewing needle, and that held the brushes in place, because I have to put springs back here. The springs go in first and the brushes go in, and these brushes push on the rotor, and the rotor is what becomes magnetized. It's called an electromagnet. Electricity goes in to these. I think the alternator will say RF on it. Let's see. Yeah. Let's see if I can show you without dropping everything. RF. So this basically is where you put electricity in to determine the strength of the magnetic field. I also want to experiment with changing how much power goes into that field. Okay, so I'm going to go ahead and put these on. It's so neat to like just see how things work. It really is. It's amazing that people figure these things out. It's incredible. They figure out how to make these, to make an alternator, to make a car. To make a city. All the things that are made. It's amazing. Okay, this looks like it goes in here. Let's see how this goes. Okay, this does look like it goes here. Let me go ahead and put this in. This says BAT, I think that's battery. So that's battery, that means this will go here. Yeah. Okay. And then I think this is next. And then this is next. And then this is next. Okay, so I'll tighten that down too. Let me tighten this side too. This is probably the ground, GRD. This is ground. Right there. Ground for this one. This one says battery, it looks like. B. I don't know if you can see that. I can barely see it myself. Right there. B. There's a B. A. BAT. So I know that's for the battery. Yeah, this alternator is very dirty and corroded. It's been sitting out in the weather. I bought it used for $15. And since the auto parts store will give me a $15 credit towards a new alternator, or a rebuilt alternator, remanufactured alternator. Since they'll give me a $15 credit for this if I get a new one, I thought it was a good idea to buy this with the chance that it might work. And then worst case scenario, if it didn't work, I could use it for a core charge, they call it, for a core, which is the value of a credit they give you when you towards the purchase of another unit. Okay, so I need to get proper wrenches for that. I think this is ready to close back up. Almost. These wrenches. Excuse me. Okay, everything's tight. That's tight, that's tight, that's tight. That's tight. Double check, yeah, it's tight. These two are tight. Ooh, interesting. So, wow, look at this. Okay, so this one is insulated. This hot wire, the positive, battery positive, is insulated from this because this is grounded here. So this is grounded, but what connects to that? It doesn't touch anything. Nothing touches that. Nothing touches this. And they call it a ground. What's it touching though? Because that's all insulated. Let me see if this touches it, what this is doing. This goes here. Oh wait, this goes this way. Oops. I need to connect that here. I gotta take that back off. Let's see. Okay, this one is the R. So what they're calling R, because that's F over there, R, this side, is this plug, which goes over to here. R goes over to here. So R goes to this. R goes to these. Wow. Well, I guess what counts is that it works. I don't know exactly how it works, because R goes to this. I still don't see how ground is ground when it doesn't touch anything. I don't see it touching anything. Ground. What's ground's touching something? It's touching the case, I guess. It's just case. The case is ground. Okay. So the case is ground. And this must be hot. This whole plate here must be hot. I'm just guessing. It looks like the plate's hot. Wow, this is so interesting. It really is. Okay, someday I might understand this. But for now, I'll put it back together. Well, I understand the basic of how it works. I just don't have a complete understanding of how it works. Okay, it looks like this might go on the bottom. Like that. These go on top. Okay, now I'm going to put our springs in. Okay, there's two different springs here. Let's see, is one of these worn more than the other one? Because I'm guessing the one that has more wear has the longer spring on it, because it's going to push harder. This one looks shorter. So the shorter one will have the stronger spring, I think. So I'll put this longer spring there. I'll put the shorter spring in here. Okay, I need to get something to push through the hole to hold the brushes in place. I'll be right back. Okay, I'm just going to use a sewing needle, and I'm going to try to use the sewing needle for the purpose of holding these brushes in place. First I'm going to put the screws in here to hold this whole unit in place here. Okay, that's in place. Now I'm going to put the brushes in. Oops. So the springs push the brushes out so that they make a good contact with the with the rotor. That's one brush. Well, these brushes are really strong. I mean, the springs are very strong. The brushes keep popping out. Oh boy. I don't remember this being that hard last time. Maybe I'm tired right now. Okay, there it is. Okay, there it is. So I have the sewing needle holding both brushes in. And I'll show you with the flashlight so you can see it better. That's just a sewing needle holding the brushes in place. And then what'll happen is once I put the, oh, there's a bearing in there too. You can see the bearing where the rotor spins in there, back inside there. There's a bearing. Ooh, there's a bearing inside there. Oh, the needle got me. Okay, be right back. I'm gonna go wash my hands. Sorry about that. Yeah, the needle got my finger. You can see it, the blood right there. See it? So I just got a Band-Aid. I don't want to get grease in there, in the cut. So just putting a Band-Aid on. There we go. Just to keep the dirt out. Okay. I have to remember that's sharp right there. The needle for the sewing needle. Okay, let's see. Let me push that through. I'm just pushing the needle through so that I can reach it on the outside of the alternator. Right there. So now I can just pull that out once this is all together. Okay, let's see. The brushes look like they're in place. I'm going to go ahead and put this back in. Oh, I forgot. See, I forgot to put something on. I'm still learning here. So there's our 3 wires that have to get connected to those, to these. Those 3 wires have to get connected where these go. So I'll connect that. Okay, let's see if we can get the get our copper coils in place here. I'm just making sure this lines up with that hole so the screw can go through. So the bolt can go through there when I bolt this together. When I bolt the front plate on. Okay, so let's get this in there. This one goes here. This one goes here. This one doesn't want to go on. I don't know why. There it goes. Okay, that's going on. Okay, so I'll go ahead and tighten these down. So I'm still learning about how the electricity works, but it's really interesting how spinning magnets, the magnetic field around this area here, generates electrons. I mean, where do the electrons come from? Do the electrons come from the copper? Does the copper have an endless supply of electrons? It's really interesting. Okay, that one's tight. Oops. Okay, that's tight. And then this one. Okay, that's all. Those are all tight now. It looks like it's ready to be closed up. Wow, this is really great. So it's all put together the proper way. And I'll go ahead and put the rotor in. There's the rotor. And the rotor has coils inside. That receive electricity and magnetize these parts of the rotor. So one side will be positive and one side will be negative, from what I understand. That's the way I understand it to work. So I'll put this in. Okay, that's in. And I'll put this on. That doesn't seem right. It feels like there's too much. It's like it's too loose. That doesn't seem right to me. It seems like some spacers should go in there. Well, it's I don't know why it's looks like it's going in too far. It looks like there needs to be a spacer here. I don't remember there being a spacer here, but it is acting like it's, oh, I know what it is. Okay, it's the needle right there. That's what it was. It's the sewing needle. Yeah, okay, that's what it was. The sewing needle was hitting it. I have a sewing needle in there holding the brushes in. And I'll pull that out in one moment. Okay. Let's see. Okay. I'm going to pull the sewing needle out that I used for the brushes, and that'll release the brushes. You'll hear them release right now. Okay. Now the brushes are rubbing on the rotor, and that's how it delivers the electricity, DC current, to the rotor, magnetizing it. And then when that spins around these copper coils of wire, it generates electricity, voltage and amperage, as I understand it. I'm still learning, but that's what it seems like it's part of what it's doing. And alternators are extremely powerful because people weld. They weld with alternators. There's YouTube videos on people welding with a car alternator. Okay, I'm going to leave this off. And see about having this drilled out, or just buying a sprocket that will fit on here, so I can do testing with that as a possibility. I know we already have 4 alternators on the scooter right now. Those are permanent magnet alternators. I just wanted to get this old alternator put together properly, and I'm glad that I was able to do that. Okay, thanks for watching the video. Have a great night and a great day. See you in the next stream. Bye.